So I'll probably be the second person during today that will not use Spanish to deliver the presentation. I have two flaws. I don't speak Spanish yet, and it's too hot for me, despite the fact that I'm living in pretty much same environment. So today I'll try to be somewhere in the middle, development and infrastructure, try to tell the story how you can move something old and non-fancy to the cloud world and how you can make this more or less reasonable from the client perspective. But before, a couple of words about me. So I'm the part of EPAM family, so I joined the company 12 years ago, a long time EPAMer. I used to have a joke that this is my second time within a company and this is my third country. So company gives me ability to travel, company gives me ability to try something new, so I joined as senior system engineer, as NOC. Now I'm covering several countries, literally. So fun fact about me, when I have spare time, I'm a volunteer firefighter and a part of community emergency response team. So trying to be not only in virtual world suitable for people, but also in real life. Couple of words, if you have any questions, feel free to ask. If you have comments, feel free to debate. So it's just our experience, the way how we did it. So there is no right solution. So loyalty system itself. Probably we'll start discussing what we've done, so a couple of remarks about the clients. In most cases, what we faced with, whenever our client tell us we want to be cloud native, they all end up in the same situation, like let's do lift and shift and we quit. And then in a month or so, they are trying to figure out what to do with the price of their bills, like skyrocketed, have no clue what to do with this stuff, and then they back to us like, we're a cloud native company, how good? How come this price went so high? Like we paid twice less during being in data center, and then now we have this strange situation. So like, okay, let's discuss this. Whenever you are moving your stuff, what you need to do, like you probably need to understand what you're supposed to move. In most cases, you will end up in a situation that there is no reason to move in general. So like there are stuff that too old, too heavy, too outdated, too like it's better to make it die where it is than to move. So once you understand what's happening with this stuff, like what's next? Next you probably need to understand where you're supposed to be.
Can you speak loudly?
Sure. Loudly?
Yeah, because they can hear you clearly.
Do you hear me? Yeah. Should I repeat all this stuff from the beginning? This is still Dennis, so I'll try to be more loud. So about the planning. Yes, you know what you have, but how far you are from the reality of the cloud, where and how you should move it. So that's time to think about this, time to plan, time to define your POCs or even MVPs if you have enough of time, enough of desire to move to the next step. So after planning, typically, like we are trying to perform the deployment, obviously, and try to prove whatever we assumed on the planning phase. Probably not all definitions were right. Probably not all the questions you set for POCs were answered correctly. So that's your way to understand yes or no. If it's okay, probably you should start thinking about moving towards more heavy migration, so moving towards production. Allow your client to test new platform, allow your marketing department to make crazy of you. Where is my old new shit? And so on and so forth. And of course, optimization. So this is vital part of any type of this exercise. You need to measure. You need to measure what's going on, and you need to compare whether it's reasonable or not. And back to my original question and the story with the client, why you're paying so long? Because you migrated your heavy database as is. You're not utilizing cloud services, but like just VMs. So welcome to the world. So that's about kind of concepts and thinkings and a little bit more in details. So like, I know it's really heavy, overloaded picture, but it's just a little bit more details for every phase. So during the assessment, we are trying to figure out what's and where. In most cases, especially if it's legacy stuff, most likely the people who know where it is, what it is, already left the company. So you need to define your infra level, you need to define your application portfolio, and figure out what you will do with this stuff on the next phase during the planning and strategy creation. So strategy, like famous 7 R's, you will define where to go, whether move, whether adopt, whether leave assist, whether die. Yeah, this is my favorite part. Despite that we are doing multiple migrations, like it's always a question like, should you spend money on this? And for me, I'm not trying to hunt for money with the clients. It's more of like being reasonable. Why you're doing this? The very first question I used to ask, like, why? Not give me people for this, but why you're doing this? Why you need this? So once you understand what's happened, once you define your plan, so basically you define the buckets for migration, the very next step is trying to prove it and figure out whether your suggestions were right or not. Like sometime happened that even though you made the right inventory on the very first phase, you know your applications, you know your physics, you deploy application to the new world, and guess what? It doesn't work. Not because you did it wrong, but because someone forgot that there is yet another connection to whatever CRM we never used before. We don't even know where it lives. So this is your way to prove. So once this part is done, more likely you prove all of your suggestions. The very next is migration as a factory. You're just repeating the buckets, you're repeating the patterns. So that's a little bit about the theory. And then let's go to the real life. So what happened? A while ago, in far away kingdom, there was a company who, like, from the retail world. So all retail, they love these perks, they love loyalties, they love points, whatever. Like dozens of clients, dozens of cards, dozens of programs, and marketing got crazy. Like, we should create something even fancier. There will be the Black Friday, we need to sell more, like we need to process this, but guess what? Whatever we have is not capable to do this stuff. So why not capable? We'll discuss this a little bit later, but reality was this was the very first call. We are in front of Black Friday. We have 2 months for the migration. Happily 2 months, not 1 month, not 2 weeks. But let's try to do something. So we start talking with them what they want. They want a platform that will be able to sustain their operation no matter what, will be flexible enough, will be portable enough, and fast enough. So I'm going to spin off new brand. Why shouldn't I have the separate platform for this? So I already have pre-configured rules to process the points. I already have pre-configured structure. So all I need to do, click deploy. Here it is. So, and like as I mentioned, integrations. Whatever we are using, like especially retail, like I barely can recall any retailer that use less than 4 to 5 underlying platform for users, for stocks, for storages, and so on and so forth. So like they need to have information somewhat accumulated. That's about business needs. Now let's try to see the beast. Again, a little bit overloaded, but in reality, so the platform contains of 2 parts. So upper part and down part, like just the more complex one is the more problematic. So while the first part is just the admin engine, so you're configuring your rules, you're setting your marketing campaigns, you're setting the policies for bonuses calculations. The second part is not so trivial. So the problem with the second part, this is what we faced with. So this is, despite the fact that it was built on top of like modern microservices architecture, this is still monolith. So this is freaking monolith, static monolith, where you perform the configuration of all your services, store in a flat file, and pray that nothing will happen with it. And the biggest issue part is transaction processing service. So literally, this is the orchestrator of all activities for the system. Like tiny shiny box represented by one single service. If it dies, you're nowhere, especially during the Black Friday. And they already faced with this situation before. That's why they decided, hey, probably we need to do something. So back to my starting points, like we need to understand what it is. We start digging and like what's inside. So the problem with transaction processor, single box, single service, no scalability. You have no clue how it works, and you're supposed to pray that it will work forever. Because if it dies, platform, no, you cannot do anything with this. And this is so heavily baked into the code, so even to start it at 27 minutes. On top of deeply customized Tomcat that need yet another 32 to start. So microservices, yes. REST API, yes. Heavy, not sustainable. So this is one part of it. Second part of it is operations themselves. So multiple nodes that process the rules, process the business logic, trying to calculate all necessary discounts, all necessary bonus programs, like tremendous amount of transactions itself. So transaction is not just one single record. This is a collection of instructions, what to do with the data, how to process it, how to calculate up or down. Then you also need to deal with the underlying user structure. Then you also need to work with underlying user personal information, like what it is, where it is. This was one of the scariest part, because they dropped the link to CRM that they don't even heard about. So this is the third-party company that maintains the record for them. So yet another piece of nightmare. And all of this fast operations supposed to live in really heavy RDBMS deployed on-prem. So again, can they live with this? Yes. Can they fork it? Yes, they can put quote-to-quote yet another cluster of this piece, but whether it will help them too much, not really, because the combination of performance of the system versus the price of the hardware, like this is pretty much insane. So what changed? First and foremost, just again, the excuse, I'm not a developer, I'm an infra guy. So very first thing we start thinking about with the guys, how we can minimize redevelopment of the platform while leveraging at most whatever Google can give us. How we can avoid the absence of service discovery in microservices. How we can scale up the system and trick the system. So make it more of like user independent, make it more of completely manageable from the vendor side, but not from the team who works with this stuff. So App Engine, fine solution. If you're using the major workloads, you don't need to do anything. It's scalable up and down. All you need to do is create the template and replica sets. So fine. Service discovery. First idea pops up. First and foremost, you don't need to take care of this scalability, quote-unquote, question, especially for the nightmare period of hot sales. Second, you don't need to think about the service discovery. So, like, you're putting to subscriber, you know where to find your events, you're fine. Then, how to get rid out of transactions. So, from transactions to events, much more easy to process, much more easy to maintain, much more easy to store. So again, heavy RDBMS, technically, yes, we can move it to the cloud. Should we? Questionable. There are still caveats, and all of us know, like Oracle is still a question for Google. So while they're trying to figure out how to sell the licenses and how to price it, what we can do. So probably Cloud SQL, probably Cloud Data Store, probably something else. Again, this is how we approached the question, and you see there's zero about development. It's pure infrastructure components. So what's next, and what happened as a result? After decent amount of back and forces with our developers, we figured out that probably, like, again, app engine for event processors, app engine for logic processors. Basically, we decoupled the transaction processing service into a set of app engine services, let them talk to each other, leveraging REST, and basically, if we see that we need something more in this particular point, App Engine can easily scale up or scale down if it's not needed. Still, we don't need front end, so who cares about fancy forms? Just REST APIs. Backend, Java, microservices, fine. So one of the tech guys from the client side was really surprised that they can pay nothing if there is no transactions. So, like, one of the things, like, we made their life cheaper. So again, you have a lot of REST calls inside, you have messages go here and there. It's still viable solution, it's still reasonable solution, but the caveat of this particular platform, again, as I mentioned, that there is no service discovery. So every time something happens, you need to figure out where is your flat file as a configuration, you need to configure ports, you need to configure endpoints, like you're almost dead. Especially if you're in rush, especially if you're talking about, like, sales events. So this is pretty much nightmare for you. So again, without no doubt, PubSub saved our life. So again, configuration of different queues give us ability to manage them properly. So if we see something happen, PubSub give us scalability, and by the way, we don't need to think about this. So it's happened automatically. That's kind of like second part of transaction processor. So and of course, data store and Cloud SQL. So probably we're still saving the flat configuration of the rules inside Postgre. Probably we use data store for transactions if you need to have a details, if you need to parse them, if you need to decompose transactions into a set of instructions. So, like, data store. User information, like baseline. So again, as I mentioned, there are still integration that bring us the user personal information, PI, so-called. But within this particular platform, username, login, like loyalty programs, person involved into, so we can store them. So that's kind of like different moving pieces and the way how we structure them and the way how we approach. Again, the biggest part of this exercise was to convince developers who originally work on this platform to rethink the approach. Like, again, I'm not trying to convert you into the bright side of infrastructure world. But still, like, again, something can be done much easier. Like, when I started working with Google Cloud, I was really surprised how fast you can arrange multi-master replication for Cloud SQL. Like, I know how much it cost me to do from scratch, but it's just a couple of clicks of the mouse. Deploy, you're ready. So try to think about this. Google provides tremendous amount of capabilities. They still have decent amount of free tiers for your apps. If you don't envision too much traffic, if you know your traffic will be localized, so try to stay, especially for the guys who are participating into startups activities. Like, this is brilliant stuff. So what we end up with? A little bit of magic. So this is how the platform looks like. And as you can see, so there is no single point of failure anymore. Everything based out of App Engine, scalable. If there is no knock into the door of API gateway, system is just sleeping and not consuming anything, except of databases, of course, and a couple of compute engine machines. You're pretty much stretched. You know how to use it. You know how to maintain. You don't need to pay too much to your ops guys who will help you. Google still provides decent amount of scalability even for PubSub. Yes, it's a little bit limited, but you still can work with them to change the limits if you need. They also provide decent availability, like pretty much enough for near real-time processing for loyalty. Even though people will buy dozens of goods during Black Friday, you will survive. That's pretty much it. Like, again, I know it's less development, it's more of on infra level, of course. We did some work to port microservices to Java and to make it native for App Engine, but in reality, it was more of configuration type of work than pure development. With that, back to you guys. If you have questions, feel free. I'll try. As much as I don't understand Spanish. Shoot.
I think the cloud is a very cool technology and it is very comfortable to use. But what do you think that we can be in some trend where when we are using some technology such as that provides only this cloud, such as DynamoDB, for example, or something else from Amazon.
I got your point.
What do you think about it and how we can prevent it to be really flexible to move from one cloud to another cloud? Because
I got a question. So first and foremost, despite the fact that I'm leading GCP practice in EPAM, I'm still trying to be cloud neutral. I can tell a lot about GCP, but the real situation is not about the cloud. A real situation is about the client needs. First and foremost, that you need to understand, and we were in a situation when we are picking up different moving pieces from different clouds and creating like complete ecosystem with the hybrid setup. Like, obviously, if you need something MLAI, it's better probably to go to Google because they know how to do the shit. If you need cheap storage, probably it's reasonable to go to AWS. If you need enterprise version of enterprise whatever, Microsoft, like there is no other way. Being cloud neutral, containers. So as of now, this is the only way you can be cloud neutral. And moreover, whenever we are doing the work for the clients, like within my team, I'm more of pushing vanilla Kubernetes, traditional one, so not locked to the vendor. It's easy to port, it's easy to move, it's easy to isolate. Of course, databases, this is heck another question. But still, even though like you can be potentially vendor locked, there are plenty of opportunities and plenty of vendors that can give you ability to go above and beyond cloud vendor. Like I know, like this company got pretty funny name for their product, CockroachDB. So they're still not analytical database, but it could be stretched among different clouds. So use it. So like again, if you're talking about workload, containers is the best choice. The closer to vanilla Kubernetes, the better. Databases, questionable. All the rest, think like again, my point is straightforward. First and foremost, think about the client needs, because in reality, they probably don't even know where to go. In reality, you are the person who is trying to help them, and in reality, like if you do things right, you will build a stronger relationship, you will become the trusted advisory partner, and this is the best thing you can do, because this will generate the money for you and for your company. It's boring, I know, like, don't get me wrong. Any other questions or suggestions? No, no.
So in this architecture, the event parser service, or whatever it is,
Mm-hmm.
it's like a single point and it's pretty
So again, as I mentioned, the problem is this platform itself doesn't work. So loyalty is just a loyalty engine. It processes the points, it processes transactions, it processes the flow of events based out of business rules. But you still need to figure out where to get these events. So API gateway gives you the ability to control the security aspect of the flow and accommodate all the sources. So in most cases, this platform will be connected to point of sales. This platform will be connected to store inventory. This platform will be connected to payment gateway, because reality, like points is virtual money. You still need to process them by somehow. Then, especially if you're supposed to convert them into real money, then this will be connected to user database. So you should have the gateway. And again, this is yet another point where you can scale your stuff, especially if you have dozens of events falling down.
Just wanted to ask you why the preference of using Java 8 as the language for your RESTful APIs? Is it a matter of personal preference, or like?
It's code base of the client. So, like, probably the dev team we work with on this solution, they'd prefer to use Python. But the client told, like, this is our and 8. And 8. And it, like, in reality, it happens, like, here and there. Like, you can suggest whatever, but you will receive the limitation. I don't want to use that. I don't want to use this. This is not security approved in our company. We don't have security advisory. Like, even this part, it took us a little bit of time to convince the security of the client to, let's say, certify PubSub. Like, VPS controls, we need to understand how it works, who is controlling this, like whether the data will be shared, here and there, fine. Google helped us. So, like, again, it's really like, again, I'll probably try to stay away from the vendor definition, but it's good if you have good relationship with vendor. Cloud service providers, they can help you to move your solution faster to the client, especially if it's related to FedRAMP, especially if it's related to HIPAA compliance, these all modern and fancy things. So you don't need to reinvent the wheel, just security guys from CSP. This is your shit. Any other questions, guys? Don't be shy. I'm shy guy. Like, I feel strange. I don't speak Spanish yet. Sure.
You know, for someone who might be starting, you know, to learn about how to manage or create architectures like this, is there any resource or standpoint that you might recommend?
So, I'm trying to remind you that I'm in for a guy. So I'll tell you my path again. When Google offered us to become the service partner and implementation partner, it was a challenge. Like, I made a call among the guys in the company, like, what do you know about Google Cloud? And got fancy response. Yeah, we know this shitty App Engine version 0.1. No. No way. So, and I back to the Google and start working with them, trying to figure out, like, how to change the vision. We spent decent amount of time building the curriculum for architects, for QAs, for developers, that literally not showing the building blocks and then explain all the patterns, like everything you can do, you can find in manual, but more of let's create a simple solution and then try to evolve it. Like, this is my storage service. Then I want to add the pre-processing for storage service. Then I want to add scalability to the service. And while evolving the solution, logically, you start thinking about how it will look with the client if you will try to build something. You're also learning new aspects of the end components of the platform. So, again, precisely for Google, they are offering quick labs, and there are dozens of simulations where you're building your service, like your application from simple bookshelf up to like almost CRM. And there are different level of complexities on every level. There are different approaches depending on which service you are trying to uncover, whether you're working on the plane and more of horizontal architectures, or you're deepening into the data services. So like architecture is more flat. They give you ability to play with every single service in different aspects of it, towards especially the scalability. And the data, there's more vertical. They're focusing precisely on capabilities of query, capabilities of data store, what you can do with this. So again, I can replay what I told by the person who built the curriculum for Google classes as well as examination patterns. So if you want to know the platform, start with Cloud Architect. Like, even it sounds fancy, but it's still like it's your ability to understand every single component of the platform. When you will understand the building blocks, literally, deep down into the data engineer. So this will give you ability to figure out what you're supposed to do with your data. And then eventually end up with cloud developer. Because you know the baseline, you know the data components, now how to combine them. So this is the idea Google put behind their certification and behind their educational programs. Of course, they have this flavor of like professional network, professional security, but these are flavors on top of it. So baseline is architect, then data engineer, and then developer. And this is sort of natural progression if you think about this. Like, I know how to build a house, now I have bricks, now I will build a house. Make sense?
Yes.
I almost finished. Don't want to bore you guys. So, any other questions? Should.
Let's see if I can make it clear. Can you hear me?
Mostly.
Okay, perfect. Since we're moving towards a future that is actually more dependent on internet,
We're already in the future.
yeah.
We missed this point already.
So basically, what we are doing is depending again on internet connection. What do you do in those cases where you need an application to work in an offline mode? For example, a hospital should not stop working because you don't have an internet connection. Outage in that moment. They will have maybe a backup plan, have different providers and on hold. However, I think the more we depend on cloud infrastructure, we don't have maybe a backup plan, or we don't have any internet. So how do we deal with those cases now?
So believe it or not, we try to solve the same type of issue, not with a hospital, but with the retailer, like McDonald's. McDonald's, like probably 6 years ago. No cloud, but still like more of network. You have availability of the network. You can send over your events, data centers, and so on and so forth. The challenge was like from time to time, someone digging the cable, not cable, but trying to plant carrots. Cable. I don't care. So we end up, and it was based on .NET that time. So we end up in a situation that we created in-house clusters that operates as a proxy and accumulates all the information, all the transactions, and then sends us a packet. You form the packet, you send it. You have the log of packets you sent. You can then trace them. You can figure out what left, what not. This in-house cluster was capable to store up to 72 hours of information. So whatever happens, every single moment where your network re-enabled, it separates two streams, like one stream is real-time stream, second stream I'm just reading out from my backup. Nowadays, Google just announced Kubernetes on-prem, so-called, or Entas on-prem, so they have the deployment of, like, again, the concept is the same. They're providing the deployable unit in-house that managed via normal Entas setup, but this is your on-prem. You have cluster in the cloud, you have cluster on-prem. Entas helps you to connect the dots like literally you're living. There is, as of now, but because of 5G, 5G opens the world and give us like real time in real life. But this is the only viable solution as of now. Hope makes sense. It's way far away from optimal, I guess. It's still, as I mentioned, we tried to solve this 6 years ago, and again, solution is pretty much the same. The question is, the technology you're using are different, but the approach is the same. Interim cluster that collects all the data and then sends over. The question is how you manage the updates on this cluster. Because with all respect to my experience 6 years ago, we were trapped once when we did not embed into the code the triggers for updates and triggers for data erase. So what's happened, like literally when we updated the cluster updated from scratch. So everything destroyed, updated. Yeah, we lost 48 hours. Fortunately, near production data, but still. So after this, we separated the updates for the schemas for database, and then updates for the main core, and then updates for the services. Happens. Any other questions? No? No. Thank you very much.